Alright, this is lesson 89 for 8th grade, and today we're talking about a system of equations. I basically have one example for us to go over today to show us how to solve a system of equations. But the first thing we need to do is get up to what a system of equations is. So it's all going to start with this example, and we'll just jump into it. It says Theo is thinking of two numbers. He says that the sum of the two numbers is 6. He also says that one number is 10 more than the other number. What are the two numbers? So we are going to be answering this question in the end here, but we're going to build up to it with a couple other things. We have a strategy that we could use called guessing and checking, but that could take a while, and we have some other strategies that we can use. So notice we are given two pieces of information about two numbers. One piece of info is that their sum is 6, and we can write that information as an equation. So x and y are going to represent the two unknowns, and we know that they sum or add up to 6. So whatever this number is plus whatever this number is should be 6. We also know that one of the numbers is 10 more than the other. So the way that they have it set up, they say that y is going to be 10 more than x is. All right? So these are the two equations that we have. So we have written two equations using the same two variables. Together, the equations form a system of equations, which is two or more equations with common variables. We often use a brace to indicate a system of equations, and that looks like that. Oh, sorry. They're sometimes called simultaneous equations. We solve the system of equations by finding the values that satisfy both equations simultaneously. There are several ways to solve a system of equations, and the method that we're going to practice is solving by graphing. So we're going to take this problem that we started with, and we're going to solve it by graphing. Now, once we are in algebra next year, they're going to show us a different way to solve this. I'm not going to show that today because it's something we're going to build up to. What we need to understand at this point is if we're looking for two numbers that satisfy both equations, we're looking for the solution where this line and this line cross on the graph. So let's take a look at each equation and graph it first. So x plus y equals 6. And remember, we graph these by doing an XY chart, and we decide what goes in for x, and we figure out what y is going to be. So well, let's just choose a couple points here. If x is 0, 1, or 2, what is y going to be? If x is 0, 0 plus what gets us to 6? Well, 0 plus 6 gets us to 6. Over 0 up 6. 1, 2, 3, 4, 5, 6. That point is right there. If x is 1, 1 plus 5 gets us to 6. So over 1 up 5. Over 1 up 5. That puts us right there. And how about if x is 2, 2 plus 4 gets us to 6. So this is what we're finding out. And we're getting a graph that looks like that. Okay? Now, how about our y equals x plus 10? If x is 0, that means 0 plus 10 gives us 10 there. Now, we could do that, but my graph is not large enough, I don't think. So let's check. 0, 10. Let's start a little lower. Let's start at, if x is negative 5. Okay? You'll see why I'm doing this in a second. If x is negative 5, negative 5 plus 10 is positive 5. Alright? Now that means we're going to go back 5. 1, 2, 3, 4, 5, and up 5. 1, 2, 3, 4, 5. That puts us there. Alright, let's try -4. If x is -4, -4 plus 10 is 6, and that's what y is. Alright, so we're noticing the difference between the equations. Here, x and y have to add together to get 6. In this one, y depends on whatever x is. Okay, they both do, but here we're not adding the 10, it's whatever x is plus 10, that's what we get for y. Okay? So -4 is 6, that's 1, 2, 3, 4, up 6. 1, 2, 3, 4, 5, 6. Let's try another one here. -3. If x is -3, -3 plus 10 is +7. So -3 up 7 right here. So we get a graph that looks like this. Okay? And my lines aren't that straight. But we should see that this graph and this graph will cross somewhere in this region. And where they cross is where our solution will be. Okay? So one good thing to do at this point is to take a look at each one's slope. For instance, between this point and this point, it's over 1, up 1. This one is over 1, up 1. And that's going to continue, okay? Let's take a look at the red one. So this one actually has a slope of 1. That's rise over run. We went over 1, up 1 each time. So the slope of that graph is 1. How about this one? In between points, we go down 1, over 1, down 1, over 1. So that's -1, 1, -1, 1. Oops. So this slope is rise over run as well, except for we go over 1, but we also go down 1 instead of rising. So it's a slope of -1, but that's okay. We're still going to be going, so we are going down, but we can follow that trend backwards too. So, looks like they're going to meet right there. Okay? Right at this point. And that point is when x is -2 and y is 1, 2, 3, 4, 5, 6, 7, 8. So this point right here is -2, +8. Let's see if that is the solution we can check. It should work for both equations. So this is our x, this is our y. Always x comes first, y is second. If I put -2 in here, I should get 8 here. So -2 plus 8 equals 6. So there's a solution. It works there. If I put -2 in over here, -2 plus 10 is 8. So there we go. That should be our solution. That means x equals -2, y equals 8, and that is that would be our two numbers. Works for both equations. It's where the graphs intersect, and that's how we can solve for a system of equations. Alright, that is all I have for us today. Like I said, we will work with this in the future, especially in algebra, where we will find a different way to do this, but this is the meaning behind it. Whenever we solve a system of equations, that's when 2 points cross, or where 2 lines cross at a certain point. Thank you.